All right, and now what about number 8? Number 8 of our shapes, 1.2 is greater than 1, so this looks like a hyperbola. So I'm expecting a hyperbola. Now, what else could I tell you? Again, you got a graph, right? I don't know much else. Some people can do it in their heads. I'm just not that skilled. So negative 6, 0 is like right here. And negative 6/11, that's almost negative a half 0 right there, right? And so there's the other one, just kind of getting myself a visual. Remember, then the focus is always at the pole, which means that makes sense that this is hyperbola. It's going like this. All right, that helps me tons, right? So what can I do? Well, first thing I can think of is I know that the directrix then is going to be here. Now, it doesn't really have to be equal distance, so be careful. That's only on parabolas, and it doesn't happen on the other shapes. So I might have a little more trouble to run into there. Our equation, though, still stays the same. So it's r equals k, then the eccentricity, which is 1.2, over 1. Now, the directrix is going to be x equals a negative number. So I know it's minus, and I know it's cosine. Oops, I forgot my eccentricity. 1.2 cosine of theta. So I know there's my equation, right? That looks pretty good. Now, I don't like the 1.2. I really wish that that was a fraction. So what is that? 1 plus a fifth. So 5/5 is 6/5. So can I rewrite this as k 6/5 over 1 minus 6/5? I don't know. It just looks, I don't know. Does it look prettier? I think it looks prettier. All right. Now I have that, right? So that's the equation. I just don't know what the k value is. However, I do have some points that work, right? I have this point right here, which is negative 6, 0. Now be careful. That's x and y, and this equation is r and theta. But luckily, I know enough to say that negative 6, 0 would work in an r theta problem. It would work beautifully. In fact, I think I'd rather use the 6/11 because it's closer to the origin and it's the one that I'm talking about. So I'm probably going to have to use this. Bummer. But again, not a big deal. The angle would be 180 degrees and the value would be 6/11, right? That would be the value because if you look in 180 degrees, you would go out 6/11. And so I could use that as my point in the graph. So what does that mean? That means R is 6/11 and K I don't know, but it's multiplied by 6/5. And I have 1 minus 6/5, and then the cosine of 180 degrees is negative 1, right? So now I just got to solve this mess of a problem that I've created for myself. 6/11 equals 6/5 times k over, was that 1 plus 6/5? So is that 11/5? 6/5 plus 5/5 is 11/5. Beautiful. I can multiply the 11/5 to the other side. And notice I get 6/5 equals 6/5 k. What? So k must be 1. I was going to divide by 6/5, but it worked out beautifully. So there it is. R equals 6/5 over 1 minus 6/5 cosine of theta. Now, most people are not going to be happy with you having a fraction in a fraction. So if you want to have really good manners, multiply everybody by 5. Now, why did I pick 5? Well, not everybody, just top and bottom. Multiply by 5/5, right? That's multiplying by 1, doesn't change it any. But notice what happens when you do 6/5 times 5. The 5s are going to cancel and you'll get 6 over, distribute this 5 through, 5 minus 6 cosine theta. That just looks pretty. I mean, what good manners I am showing, right? And that would work in the reverse too. Notice at this point, the one up above, I knew eccentricity was 6/5, but now I don't, right? In the red one, I don't know the eccentricity. I would have to divide everybody by 5. Why? Because there's not a leading 1 in the denominator there. So that's would help me divide everybody by 5 and then tell me what eccentricity was. All right, hope that helps. Stay happy.